Hello, this is part 3 on our section for piecewise functions. In this video, we're going to do a more specific type of piecewise function, and that's something known as a linear spline. Now, a linear spline, first of all, works best if you have distinct x values, preferably with no large gaps between the x values. If you're given endpoints, then we'll need n-1 linear functions. And that's because a linear spline is basically just connecting the dots with lines. So we're going to connect two consecutive data points with a straight line. And that's basically all there is to it. And of course, with your algebra skills, you can do this by hand. We could certainly program a computer to do this, but we'll do an example by hand, and then we'll see another example in a future video that's more sophisticated. But let's focus on linear splines for now. So for this example, we're going to keep it simple and just use 4 data points. And so notice what we have is a data point here at 0, 0, 1 at 2, 4, 1 at 6, 1, and 1 at 9, 5. And so visually we can draw a linear spline. We can just say, all right, we've got a straight line from here to here. And in fact, I can go ahead and define that function, because we know the slope, right? The slope is just rise over run, which from here to here would be a rise of 4 and a run of 2. So that's just 2 times, and I'll use the point slope form of a line. So x minus, we'll just use the first point, x minus 0 plus 0. And that's going to be valid when x is between 0 and 2. We can connect the next 2 dots. And now notice in this case, my slope, I went from 4 to 1. So that's a negative 3 from 2 to 6. That's a run of 4. So that's negative 3/4. X minus 2 plus 4. And that's valid when x is between 2 and 6. Notice it doesn't matter whether I put the equal sign, because this is a continuous function. So it does work whether I plug in 2 into this formula or into this formula. Notice here I'm going to get 4, and here I'm going to get 4. And then our last piece is this line, where in this case the slope is, now we're going from 1 to 5. So a rise of 4, a run of 3. And so our slope is 4/3 x minus, we can use this point here, 6, 1, quantity x minus 6 plus 1, and again, x ranges from, say, 6 to 9. So this is our linear spline. And the nice thing about linear splines is that you can immediately do linear interpolation. If you've heard that term, is just plugging in. So for example, if I wanted to estimate what the value would be, say here at 4. So estimate y at x equals 4. I just find f of 4, which of course f of 4 is going to correspond to this point right here. So this function, so negative 3/4, 4 minus 2 plus 4. Or what's the same thing, negative 3/2 plus 4. And then that works out to 4 is 8/2, so 5/2. Now, we don't know anything about the source of this data, so we can't analyze the model and see if this is a good fit or not. But if we did, we could compare and see if 5/2 was relatively close to what we're expecting. The nice thing about a linear spline is that if this isn't accurate enough, if I have a way of collecting more data, say maybe taking more measurements, then I can do so, and I can just keep finding straight lines that connect all those dots. So if I have the ability, I can make as fine of a grid, so to speak, of x values and get a better and better approximation to whatever curve I'm trying to approximate. But that only works if you're allowed to take those types of measurements. Now, there is a downside to the linear spline, and it has these sharp corners. And there's nothing we can do about that when we're using straight lines. But in the next video, we'll see a solution that gets us a smoother curve, if that's helpful. And that's it for now, so we'll see you in the next video.